Good morning. Today we're going to continue our lessons on statistics, looking at whether or not we have randomized comparative experiments. Before we do that, here's a couple of problems from the previous day. Take a look and pause these while you're looking and see if you can come up with the answers. So a researcher places 20 plants in natural sunlight and 20 plants in artificial light. The researcher then compares the growth of the plants after 10 weeks and determines which light is better. Which type of data collection is this? Right, it's experiment. Changes one thing about how much light they get, and that makes it an experiment. How about question 2? A researcher records whether people at a gym clean the machines after they use them. Right, that's an observational one. The researcher isn't interacting, isn't doing anything with them, just recording and observing what he or she sees. Okay, you should have the notes with these definitions. If you don't, make sure you put them in your notes. But a controlled experiment is where two groups are studied under identical conditions, except one variable is changed. That's like the one we just looked at with the plants. Control group. That is your group that under ordinary conditions has no treatment given to it. The treatment group is obviously the group that receives the treatment or the changed condition. A randomized comparative experiment is where subjects are randomly assigned to the control group or the treatment group, and it's used to minimize bias and increase the validity of the results. When we randomly compare things, then we have the best experiment possible. And a placebo is what's usually given to the control group so they don't realize they're not taking the treatment. It's a harmless, unmedicated treatment that resembles the actual treatment, so you do not know which group you're in. Sometimes mental thinking can influence how you think your experiment's going to turn out. All right, so we're going to look at this first example. You have it in your notes. We're going to determine whether each study is a randomized comparative experiment. If it is, we're going to describe the treatment group, and the control group. If it's not, we're going to explain why not and discuss whether the conclusions drawn from the study are valid. So we're going to look at this one together. So at a health clinic, patients were given the choice of whether to take a dietary supplement of 500 milligrams of vitamin C each day. 50 patients who took the supplement were monitored for 1 year, as were 50 patients who did not take the supplement. At the end of 1 year, patients who took the supplement had 15% lower cholesterol than patients in the other group. So let's see, what do you think? Is this a randomized comparative experiment? It is not a randomized experiment because the participants choose whether or not they take the vitamin. Since they choose, they're not randomly being assigned, and there could be other factors that are influencing why they had the improvement in the cholesterol. Could have had different eating habits, could have been on some other sort of medication. We don't know for sure. We can't say that just taking the vitamin C each day made an impact. All right, I want you to take a look at this one at your table. Determine again whether it's a randomized comparative experiment. If it is, you're going to describe the treatment group, and the control group. If it's not, you're going to explain why not and discuss whether the conclusions drawn from the study are valid. So talk at your table, take a few minutes and pause this video so that you can talk about whether or not you think it's a randomized comparative experiment. So we're going to test the new design of a self-checkout. A grocer gathered 142 customers and randomly divided them into two groups. One group used the new self-checkout and one group used the old self-checkout to buy the same groceries. Users of the new self-checkout were able to complete their purchases 16% faster. Okay, yes, this is a randomized comparative experiment. Why? Because they were randomly divided into two groups. We have the control group, they used the old checkout method, and we have the treatment group, they used the new checkout method. What is the treatment? It's the new machine. Because it is a randomized comparative experiment, the conclusions are valid, so we can satisfactorily say that this new checkout machine helps improve the amount of time it takes to actually check out. Okay, here's your last one. I want you to try this on your own. A recent study shows that adults who rise before 6:30 a.m. are better drivers than other adults. The study monitored the driving records of 140 volunteers who always wake up before 6:30 and 140 volunteers who never wake up before 6:30. The earlier risers had 12% fewer accidents. Think a minute. Is this a randomized comparative experiment? If it is, describe the treatment group, and the control group. If it's not, explain why not and discuss whether the conclusions would be valid. So pause this here and do that for yourself. All right, this is one of those that is not a randomized comparative experiment because they volunteered again. Yes, there is a treatment and there is a control. They are doing the 6:30 before and after 6:30 waking up times, but it's not, since they're being able to volunteer, we don't know what other factors could influence. Traffic, for example, could be an influence. If you're leaving before 6:30 a.m. or if you're leaving earlier in the morning, is there less traffic? And so you would have less chance of getting in an accident. Do you have better driving habits? There are just too many things that are unknown, and so the results of this study are not valid. Okay, so now we're going to look to see if there are any potential problems with the experiment as it's described. It says a pharmaceutical company wants to test the effectiveness of a new chewing gum designed to help people lose weight. Identify a potential problem, if any, with each experimental design, and then describe how you can improve it. So the company identifies 10 people who are overweight. 5 subjects are given the new chewing gum and the other 5 are given a placebo. After 3 months, each subject is evaluated and it is determined that the 5 subjects who have been using the new chewing gum have lost weight. What are some potential problems you could see with this? Here's some potential problems. 1, 10 people is not enough people to really make a valid study. If we increase it maybe to 100 people, that would help us improve it, and that might give us a better result. We also don't know what other factors might be influencing the weight loss. So for example, don't allow for exercise or don't change your current habits or something so that we know that it's only the gum that is impacting whether or not they lose weight. Okay, so we have the same type of problem, but now the company is going to identify 10,000 people who are overweight, and they divide them according to gender. So females are receiving the new chewing gum, and males receive the placebo. After 3 months, a significantly large number of the female subjects have lost weight. So what's the potential problem here? Well, they've fixed the numbers, so that's not a problem, but what would be the potential problem? Right. Since they're being divided by gender, they're not equal groups. Females and males have different body types and different hormones and things going on that could impact their ability to lose weight. And so dividing by gender is not random. If we randomly assigned and mixed the genders, then this would be a much better study. Okay, so here's the exact same problem, but now we're dividing groups according to age. And within each age group, subjects are randomly assigned to receive the new chewing gum or the placebo. And after 3 months, a significantly large number of the subjects who receive the new chewing gum have lost weight. This is a much better design. It's large enough so that we have 10,000 people, so we're really doing a good sample size. The subjects are divided according to age and then randomly chosen within each age bracket, so we know that they should have similar factors. So this would be a good design, and we could say that the chewing gum appears to help patients lose weight. Okay, so those are the types of problems for this particular piece. We're going to take a few minutes and give you an opportunity to work on the homework. There's not very many, and it should be open online for you. We're going to do page 623 to 624, problems 3, 4, and 11 through 13. Okay, this is the second part of today's lesson, and we're only going to talk about margin of error. Margin of error is given as plus or minus 1 over the square root of n. And we can use this to create an interval of how accurate we think the results might be. A couple of things you need to write down. First of all, you need to write down this formula. You need to know that n is the sample size, so the number of people that we're surveying. Your margin of error is plus or minus 1 over the square root of n. And then to find the interval where the actual parameter would be, we're going to add or subtract the margin of error from the percent. So pause a minute if you need to and write that down. All right, so now we're going to look at this example. In a survey of 2,048 people in the U.S., 55% said that the television is their main source of news. What is the margin of error for this survey? So we need to go back up here and we need to use this number, this 2048. Remember, our margin of error was plus or minus 1 over the square root of n, which in this case is 2048. Which when we put that in our calculator gives us plus or minus 0.022, or if we want to write that as percent, plus or minus 2.2%. Remember to move the decimal 2 places to the right to change a decimal to a percent. Now, 55% said that the television is their main source of news, and so we want to know what the interval is that is likely to contain the exact percent of all people who use television as their main source of news. So we take this 55%, we're going to subtract the 2.2% and get 52.8%, and we're going to also add the 2% and get 57.2%. So somewhere between 52.8% and 57.2% of all people use news as use the television as their main source of news. The actual number would fall between that based on that margin of error. Okay, so this next one I want you to try. In a survey of 1,028 people in the U.S., 87% reported using the internet. We want to find the margin of error, and then we want to give an interval that is likely to contain the exact percent of all people in the U.S. who use the internet. You will need to know that margin of error formula. So try this on your own, and we'll check back in just a minute. All right, so our margin of error was 1 over the square root of 1,028, which ends up being about 0.031 or 3.1%. The interval would be to take that 87 and add the 3.1% and also take the 87 and subtract it. So the actual number of percent of all people in the U.S. who use the internet would be between 90.1% and 83.9%. Okay, there are 2 more problems I would like you to do today on pages 630 and 631. It's problems numbers 17 and 18. It should take you just a few minutes, and then if you don't have the homework from the previous days done, go back and look at that. Remember, we will review tomorrow and have a PC on Monday.